Alright, we're going to have a test tomorrow. So, let me look this up. There was one definition I didn't include yesterday. Oxidation state. It is the hypothetical charge that an atom gets if all bonds of different atoms or different elements were 100% ionic. So oxidation state is a hypothetical charge that an atom gets if all bonds of different elements were 100% ionic. So we haven't done covalent, but the difference is ionic is where the electrons are fully given, so fully donated or given, or the electrons are fully taken by the atom. Covalent is where the electrons are shared. And I'm probably misspelling covalent. Yeah. Covalent is where the electrons are shared between multiple atoms. So when we were doing the analysis, so let's look at phosphate, or let's look at chlorate. So that'd be ClO3. Remember the oxidation state for this, so it's in group 7, but group 7, well, let's subtract 2. So it has an oxidation state of 5. And then the 6 oxygens get a -6, so this has a net charge of negative. This does not mean that the chlorine atom has a charge of +5. This is the oxidation state. Usually I will say it has a charge of +5 for easeability and thinking like it. But this is the hypothetical charge if we assume that all the electrons were completely given up. But what it's doing is it's sharing 5 electrons with oxygen. It's, and 1 electron from the 3 oxygens is shared with air, and it ends up being happy. It ends up having 8 electrons overall. But for most purposes, you can think of oxidation as being the charge. But no, there is a difference between the true charge of something and the oxidation state. For the most part, it doesn't really matter. At least not at this level yet. And I guess I'll include this definition. Oxidation means loss of electrons. Let's see if I can get a better definition. is technically, well, let's redox. Yeah, oxidation is the loss of electrons or an increase in the oxidation state. Meaning this theoretical charge increases. That's what oxidation. We'll get to this later in the year. This is what's called an oxidation state because these numbers are always positive, meaning we are losing electrons. So on the test, there is going to be some definitions and matching, multiple choice problems, let's see. This is 2 negative. Which of these is a cation? Yeah. Ammonium. It's the only positive one, so a cation has a positive charge. What is the charge of a phosphorus ion? Oh my goodness. I can't spell. So it would be 3 negative. And its name is phosphide. So everything we covered yesterday too. Yesterday was part of a review too. Is this an ionic compound? Why not? That's one thing you could look at it, but there's a formal way. So what is the electronegativity value of hydrogen? 2.1 to 2.2. And what about the electronegativity of oxygen? 3.0 to 3.44. So if you do 3 minus 2.1, that's 0.9. If you use these other values, that is 1.24. And what value does it have to be greater than to be considered ionic? 7. You have to check if it's greater than 1.7. I need to confirm. So on the test, I'm using this one. I don't know if that's the best one. Doesn't really matter. I just found one that has very precise values, but I'm looking at it. And basically it doesn't matter. You just use whatever values are on the test. But this will be on the test. You just have to memorize 1.7 and how to figure this out. Can y'all see all the numbers? So this only really works for binary. Magnesium sulfide. Is that ionic? So if we use the values on the board you see here, 3.1 and 2.58. So 2.58 minus 1.31, that is 1.27. Or if you use the values that are currently on the back of y'all's periodic table, which has a lot of mistakes in it, it had 1.2 and 3.5, which would be 2.3. What did I do wrong? Sulfur is... Yeah, this is way off. I need to find a good one. I cannot find a good one. And I have confirmed on the test that regardless of the values, they all answer correctly. So what is the electronegativity of sulfur? Which one of these is more accurate? 2.58. 2.58 is the electronegativity of sulfur. So this one on the back of your periodic table is wrong. This is most definitely 2. This one's off. I've just have so many copies of these and we haven't used them throughout the year. But I will give you a correct one to use. This seems to be very accurate and correct. This makes correct predictions, and regardless, you just need to know how to use this table. You pick 2 numbers from it and check. Because if you use the current one on the back of the periodic, it tells you that magnesium sulfide is ionic, and it's not. And I love this. So is magnesium sulfide ionic or covalent? Someone went up, found the periodic the values we got, and said that it is actually ionic. But then if we actually look up the official from chemical nature, it tells you that the bond is actually a polar covalent. They actually use the more correct values and see that a difference of 1.3. Also, remember what I said about this is a sliding scale. We just there's no defining point. This is ionic. This is not. We just have 2 scales on this system. The closer you move to the right, we call ionic. The closer we move to the left, we call covalent. Or not ionic. It's not really you are ionic or you are not ionic. It's really how much ionic you are. Does that make sense? And we just arbitrarily decided that everything greater than 1.7 we're just going to call ionics. Everything less than 1 we call covalent. And everything in the middle, I forget what number cutoff this is. I'll just put X because I don't remember it. Everything below this point is covalent, and everything in the middle we call polar covalent. We'll get into covalence next test. But the importance is just be able to recognize, because some of the names are going to change and we have different things. You can see here that they use the definition of greater than 2 is non-covalent or ionic, and everything less than 2 is ionic. Polar covalent, I don't know how they got up with that. But anyway, just remember 1.7 and use the values we're all in the test. So let's do another one to really home this in. Calcium fluoride. Would that be ionic or not ionic? Calcium and fluoride? Yes. So this is 1. This is almost 4. 3 is most definitely ionic. So that's approximately 4. That's approximately 1. So 4 minus 1 is 3. 3 is greater than 1.7. Ionic. So note, this has a subscript here of 2. Subscripts do not play a role in determining whether or not something's ionic. Several questions that ask you to write the name. So there'll be a long blank, and you must write the name of something. For example, what is the name of this? Don't use ferric or ferrous. I taught you that if it has multi-oxidation states, a specific way. It's usually not ferric and ferrous aren't usually used. So ferrous would be iron oxide or rust? Yes, this would be iron. Not rust either. What? What I'm wanting is the IUPAC name. So this is according to the rules used in class. We write the name of the cation, and if it has multiple oxidation states in parentheses and Roman numerals, we write the charge. And then we write the name of the cation. So if it has multiple oxidation states, that was one of the rules. So the rules I went on to the in the PowerPoint are the rules you need to follow. Which one was it? I even should go back to it. So binary naming is cation with no change. Anion, you take the root word and put the prefix IDE after it. So magnesium chloride. Polyatomic ions or ternary naming. Name the cation, name the anion without any changes. Multiple oxidation states. The naming scheme is write the name of the cation, put the Roman numeral representing the oxidation number or state of the metal in parentheses, and do not indicate the charge. So iron 2 chloride, iron 3 chloride, like this. These are the IUPAC naming schemes. This name is the common name. And ferric or ferrous oxide is an outdated name. The only time I'll say to use a non-IUPAC name is the by names, because they are so common. So this is the main reason for by. If you actually pull up your baking soda and look at it, it uses the outdated chemical name. If you were to go into my lab with all the proper chemicals in it and look at the chemical drawers, you would see it labeled in a chemistry lab as bicarbonate, not the currently defined naming scheme. That's because you don't need baking soda to live. What would be the name of what's a good element? So this is ammonium, and so that's the name of the cation, and then one chloride. Remember that ammonium is the only positive common ion. Almost all the other polyatomic ions are negatively charged.
What is that drum?
H3, or no, O. It's in, so remember how I said you can treat water as an acid and a base? It's the protonation of water. Whenever you put, remember charges don't like to be in water, so when you put acid in the water, it gives H plus ions. That's what the definition of an that's the definition of an acid. However, it doesn't like to be by itself, so it comes over to the water molecule and hangs out. The oxygen is slightly negatively charged. We'll get into polar covalence, and so it temporarily makes H3O plus. Also, water can occasionally break apart and produce it, and you can look this up. For example, two water molecules can come apart and do some funny things. So two water molecules, this symbol here means it goes back and forth between these two states. We'll break a hydroxide and a hydronium ion. It's well beyond the scope of a high school class, though. Or it's not beyond, but let's see. I'm trying to think of any major things I'm missing. Oh, there is percent composition. So, water. What is the percentage of hydrogen and the percentage of oxygen? So there are. So the total. I'm just going around. Well, I can look it up. I have it right here. So there are two hydrogen. So 1.00794. There is one oxygen, which is 15.9994. So the total molecular weight of that is about 18. Which is 18.01528. And so for oxygen, we do 2 times 1.00794 over 18. Which gives us 11.1898%. And likewise for this one, it'd be 15.9994 over the 18.01528, which gives us 88.81%. So there'll be a few questions, like 3 questions, where you need to find the percent of one thing in it. I will say this, though. Let's do this example. I don't think I covered this well enough. So NH3 what's the charge on NH3? It's just a plus. I'm realizing what I did. I just made something up. I didn't make a valid chemical. Let's do 5. And let's do OH 7. What is the percent hydrogen in this? So, how many hydrogen do we have in total? This is the point I was making. So, we have 3 in here in parentheses, but on the outside, so we have 3 hydrogen inside here, and it's being multiplied by 5. So this right here is 15 total inside here. This 3 and this 5 multiply. So NH3, 5, is the same thing as N5H15. And then this O gets a 7. This hydrogen gets a 7. And we can combine the 2 hydrogens together. So 22. Like that. So the percent hydrogen would be 22 hydrogens over 5 nitrogens plus 22 hydrogen plus 7 oxygen. And you just need to look out what the H, the N, and O is. O is equal to 15.9994. Nitrogen, if you look at the periodic table, was 14.00674. And hydrogen is 1.00794. And I'll actually just give you the answer so you can look at this on your own if you want to. So 5 nitrogen plus 22 hydrogen plus 7 oxygen. The answer is 10.859%. I have a bonus where I ask you based on grams. What's the formula? Actually, I have 2 bonuses. One of them is future talk we haven't covered. You might be able to figure it out. I wouldn't worry with it. I asked you basically how much is needed to do a reaction. That's end of the year stuff. But it should be able to calculate it, but I doubt you'd have time. I talk about acids. I also have a large table that will look something like this. So I have a table on the test. We will have, for example, cations on the top. So chlorine here, and then I'll have calcium here. And basically write down the reaction, or the compound formula when they react. So this would be CaCl2. If it reacts instead with sulfur, well, that's a 1-to-1 ratio, so it's calcium sulfide. And if it reacts with SCN negative, well, I need 2 of these to react with that, so it'd be calcium SCN2. Where's a good 3 one? PO4 3 negative, so that'd be calcium 3, PO4 2. Make sense? Basically, you're just crossing these 2. So this square here represents what happens when Ca2 plus and Cl mix, crisscross. The 2 is going to come over here. The 1's going to be going there, but we can ignore 1. In this table, I'll also have names. So I might do, instead of formula, I might do oxide. So calcium oxide, well, I know oxide is O2 negative. Calcium is Ca2 plus, so that's a 1-to-1. So CaO. You are not going to be given this table. So let me quickly go over things that need to be known. I want to say that all the naming the iron, cobalt, nickel, copper, and lead, and mercury. I'll just go ahead and tell you. Iron and copper and lead are the 3 ones you need to remember. Need Roman numerals. Those 3 chemicals are used quite extensively. OH has a negative charge. Ammonium is NH4 negative. Positive. At the very back of the page, I do give the correct spelling of ammonium. But not the formula. But the formula is given throughout. You'll see NH4. So you'll need that to memorize the oxyions and their charges. Shouldn't be that hard. There's a nice rule. Does everyone basically have it memorized on how to do it? If I give you on the test, by the way, here's a nice little trick. If you see on the test, I've written this formula here. What's the charge on ammonium? Plus. My point is, if you don't know the charge of something, go throughout the test and let's say, for example, SO4, Ca, calcium, this. You can work out that this would have a +5 charge, this would have our +6 charge, this would have -8 charge, and so the sulfate ion should be -2. Or you can just recognize that calcium is 2+, and this has a 1-to-1 ratio, so this is 2 negative. You get what I'm meaning? You can look at an existing formula on the test and figure out the charges and see if you're right. I did notice this one problem that has like a lot of hydrogens in it is wrong, most definitely. I think. No, it's not. It's right. Never mind. I was looking at it wrong earlier. Let's see if there's anything else. The acids, you need to know the acids. How to name them, the rules. How to figure out if something contains a copper 2 ion. We did that with lead earlier. A question, what is the proper name of something? And then it gives multiple choice. So for the most part, everything's multiple choice. So the first 7 problems is matching. There is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. 19 multiple guess. There's a table that is 4 by 5, so it has 20 parts in it. This is a little long test, by the way. There is 5 naming problems and 5 ionic versus not ionic. 3% composition problems, and then 2 bonuses. So that was 7 matching. 19 multiple choice, 20 for a table. Five naming, 5 ionic versus not ionic, and 3% composition. And there'll be one bonus of our empirical formula. And one bonus over how many grams needed to react something. And this one we have definitely not covered. Any questions? I don't really see any trick questions. For the most part, as long as you memorize the rules, there's not too much memorization. If it's a transition metal, I'm pretty sure I have to test it up, that if it's a transition metal, it's going to be multi-oxidation state. And I try to avoid, I am going to give you NH4 plus. The charge on it and the correct spelling at the end. So there's no questions. I just recommend you study on your own time. You got a game tonight, which means probably studying other classes or lunch.